Okay, so this section should finish off chapter 2, and we start out talking about transversals, which you use quite a bit in various proofs. A transversal is a line that cuts two other lines. So this would be the transversal because it cuts through both of these. When you have a transversal, it creates angle pairs. You have your corresponding angles, like these. Those are corresponding angles because they're relative to this line, they're in the same position. These two would also be corresponding, as with these and those. So those are corresponding. And they're often abbreviated as CA. Also, you have alternate interior angles, often abbreviated by AIA, alternate interior angle. Those would be these two. So that they're on alternate sides of the transversal, but are on the inside of the set of lines. Okay? In the same way you would have it there, and there. They're on alternate sides of the transversal, but they're both in the interior of the two separate lines. Okay? And the last type of angle pairs that are created by transversal is alternate exterior angles, abbreviated by AEA, alternate exterior angle. That, from the other ones, you can probably assume what it is. Alternate, so it's on alternate sides of the transversal, and exterior, so it's on outside of these lines. And those are alternate exterior angles, as are these two. Okay. Now, in the event that these lines are parallel lines, that means that there's some conjectures about those angles. There you go. So if I have corresponding angles, and these two lines are parallel, the corresponding angles are congruent. Also, alternate interior angles are congruent. Again, this is only if these lines are parallel. And lastly, alternate exterior angles are congruent, which would be these. I can, here, just for some kicks and giggles, I'll prove this one for you. I'll save this one, so it would be a good question for a homework assignment. So I'm going to prove that alternate interior angles are congruent when cut by. So if you have a transversal cutting parallel lines, the alternate interior angles will be congruent. For the sake of this experiment, or for the sake of this proof, I'm going to label this one angle A, angle B, and angle C. Okay? So, what I want to find is I want angle A to be congruent to angle B, because that'll prove that the alternate interior angles are congruent. So what I'm going to do is I'm going to say, my first step will be that angle B is congruent to angle C. And what reason can I give for that? Well, they're vertical angles, and we've already shown those. So those are vertical. And now we can look at these two and go, oh, angle A equals angle C, right? Because what we just talked about, corresponding angles. Okay? And now we know angle C obviously equals angle C. So I'm going to say, I'm going to substitute angle B in for angle C. And my reasoning for that is substitution. So that's one way you can prove the alternate interior angle theorem. So for later in the homework, I'll have you prove alternate exterior and is pretty much similar. Alright, the converse of those. A converse statement is when you switch the if and the then. Because a proof usually works like, if this, then this. Like, if it has two sets of parallel lines that are each the same size that have 90-degree angles, then it is a square. Then the converse would be saying, if it is a square, then it has two sets of parallel lines that are congruent and 90-degree angles. Alright, so we're going to try to do the converse of this, of the alternate interior angle, which states that if angles are alternate interior angles, then they're congruent. So if we're creating the converse of this, then we're going to switch the if and then statements. So now it's becoming, if angles are congruent, then they're alternate interior angles. Well, if you just think about that for just a minute, it's pretty obvious that the converse is not true. False, 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 false. Because these two angles are congruent, because they're vertical angles. They're not alternate interior angles. They look nothing like this. Nothing at all. But these are congruent. Therefore, the converse of this statement is false. However, some are true. What do we got for time?
We have 3 minutes.
Okay. Alright, so now we're going to use some examples for this. I'm going to call this line R, line S. R is parallel to S. That's how you write it out. Cut by transversal. 63 degrees. Finds W, X, Y, and Z. Okay? First we'll start with Z. It's pretty easy to find. Corresponding angles. So they're congruent. Now that we know Z, 63, we know W, because these are vertical angles, and vertical angles are congruent. Okay, now we know these two angles, and we know these two have to be equal, they have to be congruent because they're vertical angles. So we know that 2 times this plus this is going to equal 360 degrees. So there's 360 all the way around. So we have 360 minus 63 minus 63 over 2. Okay? So that's 214 over 2 equals 107 degrees. So if X and Y will equal 107 degrees. Alright, another example. This time we're going to have line P parallel to line Q. And also we're going to have a separate line here that's perpendicular. We're given this angle is 100 and we want to find X. Well, there's no formula to go straight from here to here. So if we just fill in the ones that we know, then we can hopefully get a little closer. So first we'll look at this and say, hey, these two are corresponding angles, so we know those are congruent. And we're like, well, now we're quite a bit closer to X. And we know that these two are a linear pair from chapter 1 or 2. Or section 1 or 2, I don't remember. So those have to equal 180 degrees. Alright? Now we know this is a transversal. This is also a transversal because it's cutting 2 parallel lines. So that means this and this are corresponding angles. So they're congruent. So those are both 90 degrees. This and this are a linear pair. They're both 90 degrees also. Therefore, 90 plus 80 plus X is going to equal 180 degrees. There's 180 degrees in every triangle. Therefore, X must equal 10 degrees.
20 seconds.
And that should about wrap it up.